carry on. Today we're going to be talking about GS1 barcodes and the mythical tilde1 character. So, what are barcodes and where do they all come from? The origins, as far as I know, is it comes from the USA Railroad. So they would have their carriages, and they would mark on their carriages with 3 bars where the carriage was going and how to shunt it around the yard. So then after that some chap, I believe, went on holiday on the beach, and he was thinking of how could he put this onto products so that he could get them to be recognised automatically. And he drew a series of lines, like something like that, or maybe some fatter ones on the sand, and then he thought, okay, so we've got that, how do we now make it so that we can actually view them, because they didn't have the camera systems. So anyway, after a long while they got stuff working, and the first barcodes were printed onto Wrigley's chewing gum. So those are the barcodes, and off they go, and they're printed on lots of products, and people like them because you can scan them through the tills instead of typing, and a lot less mistakes. Then people decided that barcode didn't quite do what they wanted, so they designed a different type of barcode. Not enough, this one doesn't hold enough information, we'll make another one, and so on and so forth. And eventually they got to making 2D barcodes. The ones that we're more familiar with are the data matrix ones and the QR codes. Quick response codes and data matrix codes. Now, after a while of this sort of people trying to put standards in, eventually the Global Standards Institute was formed, and they started to set about laying down some rules on using barcodes in particular products. So this is where the GS1 comes in. This is the group that started it. So what they said is, well, let's look at where barcodes are being used. So you could have something being made in a factory. You could have it being transported. You could have it going to a shop where it's sold. Then they started to delve into these things, and they found out that, okay, in the factory we might make a tin. The tin is put together with other tins, and that's put into a box. That box is put together with other boxes, and it goes on a pallet, and so on as they build up. And they thought, okay, so at every stage we could identify what is in that tin, what is in that box, where's that box going. From the factory, we could then track it when it goes out on the transport, we could track it to the shop and track it when it's sold. Not necessarily a connected system, they were thinking. They were just thinking of these are, if we could scan the barcode, it could tell us what was on this pallet. So we would have a barcode on the outside of the pallet. So to do that, they said, right, well, now we need to put in some information, but the information needs to be a rule, if you like. So if it says we're going to have a serial number on here, there needs to be a rule that says that serial number is going to be 11 characters long, and it's going to be only A to Z and 0 to 9 in the serial number, and so on. So they got down, they started setting out these rules. So they said, right, the product doesn't need to be so complicated because it just needs to identify the actual product. The box needs to be a bit more complicated because it needs to identify the product in the box, but also the box and maybe where the box is going. Is it part of a consignment? Is it part of a load? And so on. So they started putting these things together, and they've got a long list of these, and they're called AIs. They're identifiers. So they have a whole list of these, and next to 21, which is how they would identify something like, say, a serial number, they would give the rules for that serial number. So next to that they would say, yep, this is A to Z, 0 to 9, and it's 11 characters. So once they've defined all these rules, then they said, well, how do we actually encode these things into some of these barcodes so that people can actually know where these things start, stop, what they are, and so on. So they had another look at things, and they came up with this, what they called function characters. So you'll hear of the word function 1. There are many more of these characters. I think there's about 9 in total, off the top of my head. Function 1 is the one which is embedded inside the actual barcode that says this is going to adhere to the GS1 standard. So as soon as it sees that, it knows, right, now I need to start looking for application identifiers. And from the application identifiers, I need to know a bit about this. So, we have the barcode and we want to put in some information. So we'll just write the information out here. So we would start the barcode with a function 1. Next to that we would put an identifier. And next to that we could put the data, or however we want to do it, that goes with that identifier. We could then do the next identifier. And so on. Now we never know when something stops and starts here. So some of these, like this one, is 11 characters long. So if after the function 1 character it finds 21, it would know to go 11 characters in to the end of that number. Then it would get the next character off. Now these come in either 2 or 3 digits, these application identifiers. And they're all unique, so it knows if it's a 2 or a 3. So we get the next one and then we'd know where we were. Now say for instance this one was what they call free text. So it's anything from say, what we got there, 43. This is anything from 10 characters to 40 characters. So you can't put, say, 10 characters in and then have a gap. So what do you do to say I've reached the end of this one? So they started thinking of other things to do and they ended up using the group separator from the ASCII table, one of those non-printable characters. So if you're only going to put, say, 12 characters in here, you would then put the group separator after that to say that that's the end of that one. It's a terminator. So it ends. After that you can go and put another character that's of fixed length. It doesn't really matter. So then during the implementation of some of this stuff in some of the barcode libraries and some barcode readers, people will say, oh, you've got to put another function 1 in here. Well, it's not quite the thing, because what actually is function 1? Function 1, in software terms, is like an escape character. It's something that says, get your attention to say the next thing is going to be something you need to deal with. As I always say, it's like the little child at the supermarket checkout, sees the sweets, grabs your arm. That's function 1, it's grabbing your arm to get your attention. So this function 1 is implemented in different libraries as the escape character for that library. Some libraries, the escape character will be a tilde. Now it's normally a character that cannot be implemented in that barcode. So things like a data matrix or a QR code, there are only certain characters you can actually embed in the barcode itself. So something like a tilde character would not be one that would be in that barcode. And then put 1 next to it for function 1. If we wanted function 2, we would put a 2 next to it. So this is nothing other than the escape character. So all it's doing is telling the barcode library, we're going to change, the next thing to change that it is the function 1 character. But how do you encode function 1? What is it? Well, it's what we call code word 232. That is the value of that. It's not an ASCII character. A lot of people start to think, oh, it's an ASCII character, number 232. No. It's a code word. Now, what's a code word? If you look at data matrix code, in the data matrix codes, you will find lots of these code words. And these code words are a binary number, 2 to the power 128. So that on its own will make 256. So all you do for code word 232 is you colour in enough characters to make the number 232. So an ASCII number, it's a colouring of the way in which it's packed into the code. In some other things, you won't have this. You might have a different type of start character. So it might be something like that, that's 5 stripes long. Like in code 128, there'll be a different start character and different end character for the function 1. So now we've got the function 1 there. So now we've got to look at the other side of how we use this and how would be a good way to use this. Because you get hundreds of these AIs, how do you know which ones are the ones you need for your product? So if we look at an inkjet printer that we've got, it can only do certain types of printing. We can't print an A4 sheet, so we can't print a shipping label. But we can print on the actual product itself. So if in medicine, you get a lot of things that come under the name of serial numbers, lot numbers, GTINs and so on in these numbers. What you would like to have is a interface with a sort of drop-down menu that said, is this a pharma product, or is this a veterinary product, is this tins of beans, and so on. So you chose your market that you wanted, and the next screen that came up and says, these are the AIs for your market, because the AIs come for those particular markets. If you remember, we had the tin could only have certain ones on it, the box can only have certain other ones on it, the pallet label that goes on the pallet, that can only have a few certain ones on it. These codes come from the GS1 standard. They say that this can only have that, the box can only have that, and so on. So once you've chosen your number, you would get this sort of menu come along where you could input data. You could have check things next to it or something like that. So when you start to input your data, of course, if you start to go over the limit of the data, because we know some data is a limit, the user interface could say that's too much data. Or if you're putting a date in, and you know you can have year, month, day, and around the world there's, do we go month, day, month, and all that stuff. If you were to start putting in something that was a nonsensical date, the user interface could say to you, that's nonsensical. Customers have a great difficulty in understanding which ones to put on their products. So it'd be great to try and help them. In some softwares that you can get out there, labelling software does do stuff like this for the customer. Once you have that on your product, got all that printed on the product, next thing is how do you scan it? So you've got your data matrix, and you've got your code word 232 in there. The camera that you scan it with, because you have to scan this with the camera, will pick up that this is code word 232, and it will decode it because it is a data matrix code as something like square bracket little d with a 2. If it was to scan it and not find that, it would put a 1 there to say it's just a standard data matrix code. All of the QR codes of code 128, anything that's GS1 standard will have an identifier that's unique And that's the first thing the scanner will pick up. Not necessarily the thing, if you scan it past the till in the shop, you're ever going to see. But if you scan it and you pick all the data up, you will pick that up. After that, you will get the data, sort of like 21, and then your data, then 22, and the data, and so on and so forth. Sometimes the manufacturer of the scanner will put this in as in brackets to say that it's AI. Other times they don't. Sometimes they put them in square brackets. There's no wrong or right way of doing that. Probably makes it easier to read if you're seeing brackets and then the data, because you can pick up the identifiers, whereas with this you'd have to go and look for them amongst there. So it's really what makes it easier for you to view. Are there any questions on any of that so far? Everyone's happy? Of course, there's all the other things, the good things about barcodes that go with this, and that is that you need to have a nice colour onto another colour, so black on white is okay, yellow on black is better for picking up by the camera system, red on green is not so good. Yes, Frank?
Could any barcode be a GS1?
It could, but it isn't at the moment.
Alright.
There are only certain ones that they use, like the QR codes, the data matrix, code 128s, and a few others. They could make any, and it's not to say that in a few years' time someone comes up with a different type of barcode that's like really good, and we all start using it. The thing is to get the most data into the smallest area in a barcode, and there are a few ways of doing such things and stuff to play with. When you look at a barcode structure, say we take the QR code, so like a version 2 QR code, which is 25 by 25. You look at something like that, and you say, well, how much data can I get into that? And then you go and look up in the table, and it says to you something like alphanumeric. You can get in, for instance, I don't know what the numbers off the top, I'm just putting them down, 32. If you go numeric, you could get in 60. And you think to yourself, well, how is that sort of happening? The reason here is that when you start, it's always in alphanumeric. Alphanumeric is one character to one of the modules that you saw. This is the data matrix module. One of those modules would be an alphanumeric character. It uses compression when we get to numbers. So if you have the number 23, using compression in an algorithm, this also goes through an algorithm, it can take two numbers together and put them in there. But be careful. If you have something like this, it'll start off in alphanumeric, then change to numeric, so it puts in an identifier. So it's adding a character in here to say change to numeric. Because you change back to alphanumeric, it adds a character in to say change back to alphanumeric. It then adds another character in. So if you were to count your characters, 1, 2, 3, 4, 5, 6, you've missed 3. It's actually 9 characters. So quite often you won't be able to get your 32 in with the way you've packed the data. So some of the tricks to do is, if you're doing numbers, always have an even set. So if you had a number like that, you can ask, if I put a leading 0, it doesn't change the value of the number, but it makes the code maybe smaller because there's an even set of digits. If we have an odd set of digits, we say change to digits, change to alphanumeric, because that becomes an alphanumeric. Whereas if we put a 0 in front, it'll just change to digits and it stays there for the whole of it. So there's different ways of looking at things and stacking the data into the code. On QR codes you get web addresses. // a very long web address for this competition. great, lovely, wonderful. It takes up a lot of space. So all you do is you go to one of those sites that shortens them, you get in there, that goes http xy.biz or whatever it comes up with, and then you stick your number after, shortening it. So there's lots of little tricks that you can do here. Okay, any questions? Everyone happy?
Is it all data in the barcode, or is there correction or detection as well?
There is correction, yes.
Right.
So if you're going to use something like a QR code, there are 4 levels of correction from, we'll look at LM, forget that, but anyway. The first one will allow, for instance, 10% of the faults of these to be faulty and still read. When you go to the highest level of correction, it'll allow perhaps, say, 40% to be faulty. But the other point here is that the higher you go, the less data you can put in, because the more corrections you have in there. So if you think of it almost having a duplicate of the data in there. So there's things to think about. Often, if we're trying to print a barcode that's 29 by 29, and we can't get the quality we want, and it's on quite a high error correction, we can always lower that error correction. Doesn't change the data in the barcode, but that means we could pop back to a 25 by 25, and we know that raster would run faster. So therefore we could print this a lot faster and with better quality, because we're coming down, whereas this one might only reach 4 meters a second, this one might reach 6 meters a second. So if we brought that down to the line of 4 meters a second, we're printing a lot slower. Okay, the raster might be faster, but we could still print it at that speed and get better quality, so we can go for a high quality raster rather than a high speed raster. Okay, thank you all for coming.